All right, we are looking at section 7.3, which is on partial fractions. And so we have in algebra, we often learn how to perform a process, and then we learn how to reverse that process. For instance, you have learned in the past how to multiply two binomials together, but then you also learned how to factor a trinomial. All right, so factoring is the reverse of multiplying. We have previously learned how to add rational expressions together. This section, we're going to reverse that process, right, to see how we can get, instead of having one rational expression, we have it separated into two rational expressions. So we're going to do that through a process called partial fractions. All right, but first we're going to review how we add rational expressions by adding these two together. So to do this process, remember we had to have a least common denominator. So looking at these two, basically those two denominators are going to make up your least common denominator. Right, so if I want to have that as my least common denominator, then I have to figure out, for this first one, how did that denominator there become my common denominator? Well, it is missing that x plus 5, so I'm going to take this numerator and I'm going to multiply it by x plus 5. So that's going to give me 4 times x plus 5. For the second one, I notice that that denominator is missing x minus 2. So I'm going to multiply its numerator by x minus 2. When I multiply those, let's see, I'm going to get 4x plus 20. And for the second one, we're going to get 3x minus 6. And once we have them simplified and they're over the same denominator, then we can go through and we can actually add those numerators together. And we can do that by combining like terms. So I have 4x plus 3x is going to give me 7x. And then I have 20 and negative 6, and that's going to give me 14. So there is my numerator now that I've combined it together over my common denominator, x minus 2, x plus 5. And then technically, I do see that that numerator does have a greatest common factor. So if I take that out, oops, I forgot to take it out of the second one. That should not be a 14 anymore. Let's get that straight. That should be a 2. We are left with this. Right, so we're going to learn the process of basically how we can take what we got the answer to be right here, how we can take that and get back to what we originally started with. That's going to be our process of doing partial fractions. Right, and this can be done through doing some systems of equations. So it's good that we just did systems of equations in that previous section, because that's going to become useful for us as we start doing these partial fractions. So again, our goal is taking, right, basically what we have right here, we're going to have something like this, and we're going to end with something like this. We're going from reverse of what we just did. This is where we're going to start with what we're doing. This is where we're going to end with what we're doing for today. All right, going in reverse. A lot of times it's useful in mathematics. For those of you that may be going on to calculus from here, this is going to be something that you're going to have to make sure that you know how to do, because it will come up. Because a lot of times it's beneficial to us to take something that might be kind of complicated and get it into something that's in a simpler term. Right? This can be done through partial fractions. And this technique is used in calculus to find areas of regions. And that's going to be something you're going to do quite a bit as you move forward and you get into calculus, is to find areas of regions. So being able to do partial fractions is going to be very helpful for you in that regard. So let's start this process. All right. It says write the following expression as the sum of two rational expressions. All right. So we know that it's going to be two rational expressions. Right? So we know it's going to be something, and I'm going to call it A over part of that denominator plus something, we'll call it B, over the second part of our denominator. Together we're going to be adding two things to get ultimately that rational expression. So our goal is going to be trying to solve for both A and B. All right. All right, so to do that, all right, our LCD is x minus 1, x plus 3. So the first thing we're going to do, right, is to multiply both sides by the LCD to, we'll call it clear all our fractions. So we're not dealing with any fractions anymore. All right, so if I do that LCD multiplied on this side, notice that that actually is going to cancel out both of them and just leave us with that numerator. When I do it on this other side, though, when I do that times this first expression, the x minus 1's cancel each other out, but leave us with A and x plus 3. When I do this one times the second part of this rational expression, the x plus 3's cancel out, leaving us with B and x minus 1. All right, so you can see here how our fractions have been eliminated. So now let's see, start doing some simplifying. Let's do some distributing here. So we're going to have 2x minus 3 equals, this is going to be ax plus 3a plus bx minus b. And ultimately, we're going to have to do a little bit of rearranging here because we want to set up two systems of equations that we can use then to solve for those A and B's. So I want to get the A's and B's together that have X's. So you can see that's this one and this one. I'm going to regroup those together. And then I'm going to do the same thing, and I want to have those A's and B's that do not have X's together. So we're going to end up with something like this. I'm going to have AX plus BX, and then I'm going to have 3A minus B. So I just did some little regrouping, really switch those two middle terms to kind of regroup and get those that have X's together and those that did not have X's together. Once I do that, then I notice from this first group, the ones that do have X's, X is a common factor that they have, so I can factor it out. And that's going to leave me with an A plus B. Right, and then I'm just going to put some parentheses here around that second group. They didn't have anything in common, nothing that could factor out there, so it's just going to stay 3A minus B. And we do this because now if we look, we have equal sides on our equation, all right? I have 2 and then A plus B that both have an X. So since the 2x and then the x times A plus B, since they both have an X, then that tells me I can set those two things equal to one another. that's going to give me one of my system of equations that I'm going to be able to solve for A or B. Then I notice that this constant and this one here do not have any x's, so they can be set equal to one another. And so that's going to give me negative 3 equals 3a minus b. I now have my system of equations, and now I can do substitution or elimination to get those a's and b's so that we can know what our partial fractions numerators were going to be. I am going to just do a little rewriting of these. I'm going to put the a, b's on the left and then what they're equal to on the right, just because that's kind of how we're used to seeing our system of equations. Right. I do notice here that easiest way I think to solve these is going to be elimination, because I notice that the b's both do not have coefficients in front of them, and one of them is positive and one of them is negative. All right, so since they both do not have coefficients, they basically both have a coefficient of 1, then they're the same, and I can add my two equations together to eliminate them. So I have, this is 1a plus 3a is going to be 4a. B plus negative b is going to cancel out. 2 plus negative 3 is going to be negative 1. I'll divide by 4. And I get a is negative 1/4. So my numerator in my partial fraction for that first part of our fraction is negative 1/4. Now that I know what it is equal to, I'll go back and plug that back in to either one of those equations and to solve for b. I think I'm going to shoot for that top equation. So I'm going to have negative 1/4 plus b equals 2. I'll add 1/4 to both sides and get 9/4. So b is 9/4. Now that I know what those numerators are equal to my partial fractions, I'm going to go back up here and I'm going to look, and you see what we have right here. I'm going to put our values of a and b in place of those, and we're going to get our partial fractions. So I'm going to have, make sure I get this right. So it's negative 1/4 over x minus 1 plus 9/4 over x plus 3. So we just did basically the opposite of what we did in that first example. Is we took something that was already combined together, and now we have separated it into two rational expressions, right? By figuring out through system of equations what those numerators were going to be equal to, right? So it's like we took apart those, that numerator that we had initially. All right, example number 3. A little bit more involved in this one. For this partial decomposition, right, notice that you have an x minus 2 squared, right? So an x minus 2 squared means I really have to write that denominator twice, or that x minus 2 twice, which tells me that I'm actually going to have 3 parts to my partial fraction, because that denominator is made up of 3 different things. So those 3 different things, right, are going to be an a over that first denominator plus a b over just one of those single terms of x minus 2 plus c over the fact that that x minus 2 is squared. So I have to divide it up, and there's three different possibilities. You have the x plus 4, you have just an x minus 2, and then you have a x minus 2 squared. All right, once we figured out that, we've separated, we've decided that it's got to be three rational expressions added together. Now we're going to multiply both sides by that LCD. LCD in this case is just x plus 4 and x minus 2 squared. Right. Hopefully we realize that when I do it on the left-hand side, right, when I do it times this right here, it's just going to leave us with that numerator. Right, the whole denominator is going to cancel out. When I do it times this side, right, times this first one here, the x plus 4s are going to cancel, but it's going to leave us with the a and x minus 2 squared. When I do it times this second one of the x minus 2s are going to cancel, but we're going to be left with the x minus 4 and the other x minus 2. And then when I do the LCD times this last one, we're going to be left with the c and the x minus 4, or excuse me, plus 4, because the x minus 2s cancel each other out. All right, so we are going to have to do a little bit of foiling here for each of these to try to simplify that right-hand side. I'm just going to keep bringing that left-hand side down. Remember that x minus 2 squared means x minus 2 times x minus 2. So let's see, if I FOIL that out, x minus 2 times x minus 2, that's going to be x squared minus 4x plus 4. When I FOIL the second 2 out, that is going to be x squared plus 2x minus 8. And we're going to do some distributing here. So distribute the A, distribute the B, distribute the C. And let's see. Oops, left off the A there. So it's going to be 4AX, and that's just a 4A. And then this is bx squared plus 2bx minus 8b. Oops. And then this is going to be cx plus 4c. All right, and so just like we did last time, first thing we want to do from here is we want to regroup those things together that have similar variables. And we're talking about like the x variables here. So I'm going to regroup these ones with the squareds together. And then those that have just an x together. And then finally, those that did not have a variable at all together. So we're just regrouping, just reordering things. Getting those, what we kind of consider like terms together. And then remember, now we're going to look at, okay, this first group, remember they had an x squared in common, so we're going to factor that out. And we're going to have a plus b. And then that second one, they have an x in common. So we're going to take that x out. And then that last group did not have anything in common, but we are going to keep them grouped together. And now we're trying to match it up with that other side. And something I noticed about that other side is that it did not have an x squared term like we have here on the right hand side. So I'm just going to let this be like a 0x squared because I'm not really changing the equation when I do that. All right, but we need to be able to have the sides match up. I'm also, all right, gonna take and put that term that does have an x here on this side, I'm gonna put that in the middle because it then kind of models our typical trinomial, which goes from an x squared down to an x down to a term that does not have any variable with it. All right, so I'm just doing some rewriting here. All right, so now we got to match up those parts to get those equations together. So I have a 0 and an a plus b. So 0, actually let's write it the other way. Let's go a plus b equals 0. And then I have a -4, and then all this part right here. So that's going to be -4a plus 2b plus c equals 0, or not 0, equals -4. And then I have 20, and it matches up to this last part, which gives us our third equation. So this is something we haven't seen yet, but having a system of 3 equations and 3 variables. Right, that first equation already has c eliminated. It doesn't have a c to go along with it. So we want to try to see if there's a way we can eliminate the c's in the other equation. So that gives us just an a and a b, right? So that we can then use it with the other equation that already has an a and a b to get rid of then either a or b and continue solving. So looking at these bottom 2 equations, trying to eliminate those c's, I need them to have the same coefficient in front, which I see the bottom one has a 4. So that means I probably need to take this one and multiply it by 4. And then we'll just slide this one over underneath it. All right, and both of those 4's are positive, so we are going to subtract these 2 equations to eliminate those c's. So -16 minus 4 is going to be a -20a. 8b minus -8b is going to be a positive 16b. 4c minus 4c is going to cancel. -16 minus 20 is going to be -36. And so now I have 2 equations that both have just an a and a b with them. If I take that first equation that we had, which already had just an a and a b, and now I bring this one over, it also now only has an a and a b, which makes it much easier for us to then solve a system of equations that has just 2 equations with 2 variables opposed to 3 equations with 3 different variables. So now we want to get, you could either take and solve one of the equations for A or B, or you could do elimination and get the same coefficient in front of either A or B. I think that might be the option that I'm going to go for. I think I'm going to shoot for trying to get the same coefficient in front of my A's, which would be a 20. So I'm going to take and multiply that top equation by 20. And we'll drop that second one right below it. Okay, now that I've done that, I can add the two equations together because they have different signs. One is positive, one is negative. They're going to cancel. 20b plus 16b is 36b. 0 plus negative 36 is negative 36. I'll divide by 36 and I get b is negative 1. Okay, so now that's awesome. We've solved for one of our coefficients here, or excuse me, numerators. Now I need to go back and solve for a and c. So I'm going to go to that first equation, the one that we have in pink, and I'm going to plug in negative 1 for b. And we'll solve that by adding 1 and get a is 1. And now that I know what a and b are both equal to, now I can solve for c by plugging in both a and b into one of those bottom equations. I think I'm going to take that middle one. So I'm plugging in a 1 for a negative 1 for b. So that's going to be negative 4 plus negative 2 plus c equals negative 4. That gives me negative 6. I add 6 to both sides and I get c is 2. And so now we've found all three of those numerators. And so we'll write them. We had 1, which is a over x plus 4, plus negative 1 over x minus 2, plus c, which was 2 over x minus 2 squared. So we just took and divided up and came up with those numerators to take that rational expression that had already been combined and divided it into its different rational expressions. Right. There are two more examples, right? And I'll kind of help you get started with these and then leave you with some of it to try on your own. First thing is this denominator number 4 is not factored. So that's the first thing we need to do is to factor it out so we can get an LCD. I see that it has 4 terms, so I think I can use grouping to factor it. So the GCF of the first group is an x squared, which leaves us with an x plus 1. The GCF of the second group is a 4, which leaves us with an x plus 1. So then I take the x squared and the 4. They become my first factor. And x plus 1 is my second factor. So that makes my LCD is x squared plus 4 and x plus 1. So then my partial fractions are going to have 2 parts to them. So the first one is going to go with that x plus 1. And then the second one, so this one's a little bit different, all right? This time, because that's an x squared plus 4, right, it has to have a linear numerator. And that linear numerator is going to be of the form bx plus c. And that's going to be over x squared plus 4. Right, so from here, you just need to multiply by your LCD on both sides, get those systems of equations, so then you can solve for A, B, and C. All right, so I kind of got you started there on that one. I'm going to leave you for the rest of it. Again, go into Moodle, check that answer key to see how you did in getting that partial fraction. All right, and then this last one here, again, that denominator needs to be factored. All right, I think for factoring this one, I think we're going to use like a quadratic technique, like a u substitution. Let's let u be equal to x squared. Let's u be equal to x squared. So if I rewrite this as 4x squared squared, you notice that x squared squared is still going to give me x to the fourth. So if I put a u in place of those x squareds that I see, you notice that that gives me something that I could factor, like slide and divide for. So let's see. It's going to be u squared plus 12u plus 36. So I need, what can I multiply together that gives me 36 and add, and we get 12. I believe that's 6 and 6. Then I have to divide both of those by 4, which was my leading coefficient. Reduce those, they become 3/2. And then do bottoms up. And then we can't forget that ultimately u was equal to x squared. So this would be 2x squared plus 3 times 2x squared plus 3. So our LCD is 2x squared plus 3 squared. Right. Getting our decomposition, since both of these have squareds, they're both going to have linear numerators. So for the first one, it's going to be ax plus b over just a single 2x squared plus 3. And then the second one also is going to have to be a linear numerator. So this is going to be cx plus d. And then that's going to be over the fact that we had a squared, a binomial squared. So that's going to be our second denominator. All right. Honestly, don't get yourself too caught up in if you don't understand examples 4, 5, right? Those are definitely the more complicated ones. I personally, the only ones I'm going to ask you to be able to do on any test or final exam is going to be something like example number 2. So make sure you understand how to do that one and you practice those the most, because those will be the ones that are similar to what you see on your test. I agree that these last 3 are a little bit more difficult and a little more complicated. Right, these, like example number 2, are the ones that you need to focus more on, the one that you're going to see on a test or on a final exam. Right, if you have any questions, please feel free to reach out.